Okay, what we're going to talk about today is the product rule. And the product rule is when you have two functions being multiplied together, and this is how you would find a derivative of them. We talked about the power rule, and or not the quotient rule, but the power rule in several different instances. But this is the product rule. And this is very important because sometimes you have the product of two functions. For example, if you have like x squared plus x plus 1 times x squared plus x. This would be like, if you look at this little diagram, you probably want to copy this down, okay? And this is what this would be. This would be like u, and this would be times v, all right? U times v. And what the product rule states is we're going to take the derivative of u. So if we write this out right here, u would equal x squared plus x plus 1. And then we're going to find du dx, du dx. And that's what we do right there. We're going to take the derivative of that, which is going to equal, if you use power rule, so you have the no power rule, I'm going to take the derivative of x squared, which is 2x, plus the derivative of x, which is going to equal 1. And the derivative of 1 would be 0, so that's what I have there. All right, so that would be our u times, our u and du. And so when you have this, you're going to take the derivative of u, so that's our du dx, times our v. Now, what is v? Well, v is the second function. So v is equal to x squared plus 2. And so dv dx, so the derivative of v with respect to x is going to equal, using power rule, 2x plus 0. Okay? So now, when you do power rule or product rule, you're going to multiply, all right, starting at the bottom, du times dx times v. So we'll just write that out. All right, so it'd be 2x. So I say the derivative of the first function times the second. So it'd be x squared plus 2. All right, plus the derivative of the, all right, second function. You go like this. So we have 2x. That's the derivative of dv times x squared plus x plus 1. From here, we could simplify this through, and I'm going to do that, and that's what we would equal w prime. So if you do a little table right here and go u du v dv, and you just multiply them and add them together, that's a little shortcut on how you can solve that. Now, I'm just going to simplify that. Normally for my personal test, I don't simplify because I just want to do some more problems, but I'm just going to simplify in this case, just to see what this is going to equal, to show you that the product rule works. So we're going to FOIL this through. So we have 2x cubed. All right, it's going to be plus x squared. That's going to be plus 4x. It's going to be plus 2, plus 2x to the third, plus 2x squared, plus 2x. That equals w prime. From here, we're going to combine our like terms. We're going to have 4x cubed plus 3x squared plus 6x plus 2. And so that would be our simplified derivative. Now, to kind of show you, all right, that we can actually solve this. Now, I would never probably use the product rule maybe for this, unless I just want to get the answer for the derivative. But we can also, if we wanted to, simplify this top function first. And so if I went through and said, okay, this is going to equal, all right, x to the fourth, all right, plus 2x squared plus x to the third, all right, plus 2x plus x squared plus 2. And if I simplify that a little farther, x to the fourth, all right, plus 3x squared plus x cubed plus 2x plus 2. And if I took the derivative of this function right here, I should have 4x cubed. I should have 6x. That should be 3x squared. That should be 2. And that will be 0. And so as you can see, using the power rule, the product rule works. The product rule works. Okay, so I'm going to go through the product rule one more time as another problem. Okay, and let's just try this one right here. Let's say we have h equals, all right, the square root of x times, okay, 3x squared minus 4. x plus 1. All right. And so right here, we have two functions, u times v. Now, what we could also do is distribute this through and do a little algebra, and I would suggest doing that. But for right now, what we're going to do is we're going to use the product rule just for practice. So the product rule states, define h prime. We're going to take the derivative of u, which we're going to call u prime, all right, times v, plus the derivative of v, which is v prime, times u. Okie dokie. And so let's just write this out. So what is u? U is the square root of x. Then u prime, or dv, or du dx, is going to equal, because that is x, so 1/2 power. We're going to have 1/2 using the power rule. Subtract 1, be negative 1/2. We're going to look at our, all right, v. Our v is going to equal 3x squared minus 4x plus 1. And then we have our v prime, which is the same thing as dv dx in this case. And we're going to have, using the power rule, 6x minus 4. So let us complete this. All right. We're going to take the derivative first times second. All right. And so we got right here, it's going to be 1/2. So h prime is equal to 1/2 x to the negative 1/2 power times 3x squared minus 4x plus 1 plus, because the product we got plus, all right, it's going to be v prime, so it'll be 6x minus 4, all right, times, all right, x to the 1/2 power, or the square root of x, however you want to write it. We could simplify this if we wish, or we could leave it like that, but that's what we have. All right. Well, let's try another problem. Here is a problem that you might see in your book, okay? And what we are given is we're given u and v. They are differentiable at x equaling 0, so that means it's also continuous at 0. It says that u of 0 is 5, u prime of 0 is negative 3, and v of u of 0 is negative 1, and v prime of 0 is 2. We're going to find the value of the derivative. So this means we're going to find the derivative of this function. So if you want to try this at home, before I tell you the answer, you can pause this video and do it now. Okay, so if you are done pausing it, you've tried it, I would probably try it out. So the first thing is we're going to take the derivative of each one. Now, the derivative with respect to x of 3u. So we're going to take each one of these individually. This is going to equal 3 times u prime, all right, or the derivative of u, because this is just a constant, or just a regular function, minus, we're going to take the derivative of, all right, 2v, not 2v, that's the question, and that's going to be minus, well, 2 times the derivative of v, okay, which is v prime. And now we're going to take the derivative with respect to x of 2 times u times v. So this means I'm taking the derivative of just this individual function. All right, so we're going to add, all right, the derivative of this. Now notice that we have 2u v. Well, 2 is a constant, and so 2 could actually just be taken out because this just comes along for the ride. That's what I say. Or you can group these together. So let's take this right here and find out what we have for our two values. Well, 2 being a constant, we'll have 2. And then we have u times v. So we have to use the product rule. So we're going to take the derivative, all right, of the first, so that'd be u prime times v plus the derivative of v times u. And that's what we got. Now, we're going to try to find the derivative at x equaling 0. So this would be our laid out solution to this. Okay, that one right there. But now let's find out what our answer is going to be. So we're going to have 3 times u prime at 0. So we're looking at this value would be negative 3. Minus 2 times v prime. All right, what's v prime at 0? Well, that's going to be 2. All right, plus 2 times, all right, this quantity, u prime at 0, which is negative 3, times v of 0, which is negative 1, plus v prime at 0, which is 2, times u of 0, which is 5. And if you add all these together, what you'll get is negative 9 minus 4 plus 2 times 3 plus 10. That's going to be 13. 13 times 2 is going to be 26. Plus, that's going to be negative 13. And then we have total is going to equal, all right, 13, I believe. That would be our answer, if I did all my arithmetic right. All right, and so that is our solution. Okay, that's our solution. So once again, when you take derivatives of these type of problems using notation, all right, the 3 is a constant, so we're using that times the derivative of u. The derivative of u, we would just say is u prime. All right, when we have minus 2v, the derivative of v, well, 2 is a constant, but what's the derivative of v? That's v prime. And then when we have 2uv, 2 is a constant, so it comes along for the ride. And then we take u times v, which we have to use the product rule in that. And the product rule, as we stated before, is the derivative of the function, first function, which is u prime, all right, times the second function, plus the derivative of the second function, which is v prime, times u. And we can do that if we set it up, boop, boop, and add them together when we're doing that. Okay? Well, I hope that helps you out with the product rule. Try some problems on your own, and we'll do some more in the future.